Hello people of the internet. For the past few weeks I've been working on an alternative way how to submit new packages to Fedora. We came up with the ideas with Mirohronchok on this year's vlog, and I finally have a prototype that I would like to show you. By the way, all of the ideas are described in my blog post. Some of you may have read it already. The cornerstone of this approach would be proposing new packages through pull requests that will allow us to have CI/CD, inline code comments, and stuff like that. The problem is into what repository we want to propose the packages into, because we don't have just one repository with all packages. But please don't turn this discussion into a monorepo discussion. Even if we wanted it, it would delay this proposal by years, because it would be a lot of work. So I don't want to do that. So as a workaround, we came up with the idea of having a intermediate repository, which we would just propose the packages into, but they wouldn't live there. So I'm running it locally on my machine, and it's called packaging/package review. Basically, this would live, for example, on the Forge fedoraproject.org. But so far we have it locally. Now, if a contributor would submit a new package, they would fork the repository, clone it, and submit new packages via pull requests, right? So let's do just that. If I go to my terminal, I already have the repository cloned, so I can just create a new branch. So, for example, git checkout b demo. And we can copy some packages from my system here, right? So we can do, for example, copy rpm build spec. Let's do hello.spec. Let's copy it here, and we can git add the hello, and we can commit git commit add hello package, right? There is no reason why we would have to limit this to just one package per one pull request. We can add multiple packages. Why not? It actually brings us some interesting possibilities. So if we copy some other package, let's do, for example, light.spec, and we can git add light.spec, right, and git commit add light package, right? So we can now push them and create a pull request. So let's do that. And we can open in the browser, right? We can see we are proposing a new pull request against the package review repository. So I'm creating a new pull request, which is add new packages for demo, and adding, I don't know, hello and light, whatever. So we can create a pull request. This is already a big improvement on top of what we do like right now in Bugzilla, right? Because we can like have a discussion here, we can see the changed files, right? So we can finally write inline code commands, fix the description, right? We can do the proper review here. So even if we had only this would be a big improvement. But of course, this is not all I have so far. So I would like to run some CI actions on top of this. Be it a packet CI, be it actually Forgeo actions, it doesn't really matter. It's an implementation detail at this point for me. However, I didn't want to bother with configuring the action runners on my local host. That would be so much hassle. So I actually I actually have a fake data to reproduce the actions locally in my terminal. So we will do just that in the demo. It's a bit clunky. It would be better if we had an actual runner here, but hey, let's imagine it's running in the CI. We will see it in the terminal. So on the pull request, a action would be triggered. So I can simulate it locally using the act command, and I can say, hey, I want to simulate a for-geo action that I have written right here. And this is my fake data that would be actually like available during an actual action within the CI. And I have some secrets because we are going to build stuff in Copr, so therefore we need Copr tokens and stuff like that. So yeah, we can reproduce it this way locally. The thing is, I have several fake data files, so I want to use a pull request open one. So I want to simulate that we just opened the pull request. And one more thing, I said it is a bit clunky. In the fake data, there is actually a hard-coded pull request number, so I need to manually edit it here. So pull request number and the branch name. Right? These data will be available when running in actual production environment. Anyway, if I run this command, we will trigger the for-geo action. And it takes few minutes to finish actually, so we will have to wait until that's done. Okay, and now it got interesting, finally. So we can see that we submitted some Copr builds. We can open them in the browser and take a look. So if I go to, I submitted them, by the way, to the Copr staging instance because I didn't want to run it against my local instance, and I didn't want to use production to maybe accidentally confuse people that might think this is already live or something like that. So I used staging instance, and if I copy the build ID here, we can see that the action created a new Copr project, which is under the Fedora review group, and the project is named Fedora review-pr3, which matches our pull request within the where is it here within the for-geo instance, right? So if we take a look on the builds within this Copr project, we can see that we have two builds here, and the first one is hello, it is already running, but the second one is still unknown and it is in pending. And it will actually be in the pending state until the hello package successfully finishes. Then we will start building the second one. And the reason being is that the second package may require the first one as a dependency, as a build dependency. And therefore, we don't want to just submit them all at once. We want to take a look in what order the user, the contributor, committed the packages, and we want to build them in the same order and actually wait until the package finishes and then build the next one, right? So that we can successfully deal with dependencies. If, for example, the user committed multiple packages within one commit, then yeah, we can submit them at once. But if we have consequent commits, we need to have consequent builds. So we can also investigate that it is done via build batches. So if we open this build, we can see it is a batch number, this one, and we can see it was blocked just a few seconds ago, but it is finally processing now, and it was blocked by this one, which it depends on, which is the previous one with the hello package, right? So I looked a few seconds later than I wanted, but actually, yeah, it's building now. So we can see it is building. So let's wait until this finishes, and we will do some more things. And the build finished, so the action should finish soon. Yeah, the action finished too, just now. So we can see that the job succeeded. That's nice. Let's talk about that a bit more. So, of course, if the builds would fail, the job would fail itself also, and would block the pull request merging, right? So that's obvious. An interesting thing to discuss is that basically, if it failed for some stable Fedora version, but it succeeded for Rawhide, we would still consider this to be a success and would finish the action successfully, because when proposing new packages to Fedora, it is nice to have if it builds for the stable Fedora versions, but it is a must and it's required for the package to build in Rawhide. So Rawhide is the only criteria that we have here. So we examine only the failure or success within Rawhide. But we are building for all chroots. You can see if we open the hello here, you can see it was submitted against all stable Fedora versions. Now this is useful because sometimes you want to support all of those and just don't know that it doesn't work for some older version. And yeah, I have some intentions for it as well in the next steps I will show you. Other thing to notice is that I only build them in the Fedora, in the x86-64 architecture. I didn't deal with the other architectures just yet in this initial prototype, but of course we need to deal with those as well. Now, I want to show you, hey, let's add, hey, I forgot, right? Let's add one more package to the repository. So let's say I have one more dependency or something like that. I want to add it. So I can copy some other package here. Let's do add.spec and let's git add spec, git commit, add package, right? I can git push it. Let's just check it is actually there. It is there. And I can run the action again, right? But this time it will only submit the one new missing package, right? It will examine that the existing packages, that the previous packages were already built, and therefore there is no reason to build them again. So it will build just the add package. Okay, we can see that the hello package was already built, the light package was already built, so we are now building only the last build, which will be, of course, the add package. Right? We don't probably have to wait until it finishes, so I can show you one more thing that I wanted to show you, and that is, what if the user decides to force push into their repository, right? So let's say they added 3 packages and they decide, hey, I actually don't need this one because my package doesn't really depend on that. I don't need that one. Let's get rid of it. I don't want to maintain it in Fedora if I don't need it, right? So they decide to, for example, drop the package from there or whatever change do whatever change, right? They can modify the hello package and force push. In that case, we don't actually what do we want to do, right? What I think is that we want to wipe everything that is within this Copr project and start from scratch, because we don't want to pollute the build root with packages that aren't supposed to be there and the user decided they don't want them there, right? So if we decide to force push, let me kill this action, we don't have to wait for it. So I have a fake data here that simulate the force push, right? So it would be this one. So we can see that we again got 3 builds. And if we refresh the project, we can see, sorry, I wanted to go to the builds. We can see there is nothing there, only those 3 builds. The previous one were removed and we are building from scratch in the batches again. And therefore, first this one will be built, then this one, and then the last one, right? So that's how the force pushes would work. Now we need to wait again until we have all of them built, and then we will see what happens when we accept or merge a pull request. So let's wait here. We can do the waiting in the terminal. Finally, our job succeeded. So if we refresh, yeah, we see the 3 builds and they all succeeded. Now, let's say that the CI check mark is green. Let's say some human reviewer actually did the review and they said, hey, this is fine, we like that. So let's merge this pull request, right? We want to accept these packages, right? So we merge it. They should appear in the repository, right? And what happens next? Next, we would trigger a script which I have right here, and that would be a import to distgit script. So you can see we are just calling some script that I have written, and we are specifying we want pull request number 3, right? Pull request number 3 was merged. So let's run the command and see what happens. By the way, I have my local cgit instance. There are no repositories found. I just refreshed. There are no repositories just yet. This is on localhost, right? And this is cgit. This is my fake distgit instance, right? I didn't want to use any like staging distgit somewhere in Fedora. I used my local instance. So for example, so this is basically a fake of the source fedoraproject.org, right? Which is currently running Pagure, will be running 4Geo in the future. I'm running it on cgit right now just for development purposes because it's the easiest, right? We can see the script finished. We can see it does some pushing, and yeah, it does some pushing. So let's see what happened. Let's see what happened. We refreshed the cgit instance, and we have some packages here already, or some repositories rather. We have the add, hello, and light. I can go to hello, for example. We can see that we have already Fedora 43, 44, and rawhide. There is the master branch, which I don't like, and I don't want it to be there, but actually in the source fedoraproject.org, the main branch or the master branch is still there as well. And you can see we didn't modify it actually. It still has the initial setup of the repo commit, but the rest of the branches has an automatic commit. I should probably improve the commit messages. Either way, the default branch is the rawhide, and if I go to the tree, we can see the hello.spec is here, right? And I can easily fed package or rpkg clone this repository and build the source RPM out of it and do whatever I want to do with it, right? So I don't want to show that, it's not relevant, I think. So we successfully imported the packages into distgit, right? All of them. Now, the branches will probably be controversial. There are ideas that we should automatically import only to rawhide and ignore the rest. That's one possibility. What I chose is a bit more, there is a bit more logic in it, but I think it works fine. I actually examine, when importing, I examine in what branches the package successfully built in the Copr project, and if it built successfully in in these, then I will import it. I will create branches and import the package into all of those branches, right? If it fails for some of those, I will not create the branch for that branch, right? So if the package succeeds only in rawhide, I will create only rawhide. And you can see, for example, the Copr uses an currently end-of-life chroot, which is Fedora 42, and it didn't affect the cgit situation here. The cgit on it, or the distgit on its own knows or figures out the currently stable branches and uses only those. So if there is some additional chroot within the Copr project, it doesn't matter. It won't affect us. We just check where it built successfully. So that's the import, right? At this point, we have the distgit repositories, we have the packages there, but what about the situation in our temporary repository? Because in our temporary intermediate repository, we have the spec files here, which is fine, I guess, but once this grows, some people may accidentally think that, hey, the packages live here, and we don't want to cause confusions like this. So I actually want to keep this repository clean. I don't want the spec files to live here any longer than they need to. Like, of course, we want to keep the pull request history and the discussions there and everything there. We just don't want to keep the spec files or any other files in the main tree of the repository, right? For that, we have a cleanup script. I can run it like this, and you can see it takes a path to the repository, and that's it, right? So if I run the script, it said that it actually removed these spec files, and we passed the push parameter, so it should have pushed things to the upstream repo. So let's take a look. If we refresh it here, we can see there are new commits within this repository. So let's go to the commit history, and we can see that they were added once we merged the pull request, and then the cleanup, for example, during the night or something like that happened. And if we open, for example, this commit message, we can see that the package hello was imported to dist-git, and I put the dist-git link here so that everybody knows where the package actually lives now, right? And we of course delete the spec file. So if we refresh the repo, the additional files aren't here anymore, right? So that's how the cleanup happens. Now, of course, this is a prototype. I didn't deal with many things, like we talked about the architectures. For example, there is one problem that the spec files were, I only dealt with spec files, and therefore it would work so far only for spec files that have fully qualified URLs for all of their sources, and therefore Copr can build them just based on the spec file, but it wouldn't work otherwise. We need to deal with situations like that. Also, yeah, if the contributor needs to have a spec file and, for example, some additional patches or something like that, yeah, only the spec files appear in the repo. So I know we need to. I only dealt with the easiest example that I could think of. All the more complicated cases still needs to be like figured out and solved, right? But other than that, this was my demo. I'm curious to see what you think about it. Would you like the process to look like this? Of course, we need to. In my opinion, I didn't strive for anything perfect. I wanted to do something that we can all agree on and move towards at least the correct direction, and move a little and then again think about our situation and move from there a little to the right direction again. So that finally in some time we can have an awesome package review process. But I want to take it in a smaller steps, because otherwise we just won't get there. Anyway, let me know what you think, and see you next time. Bye bye.